Hi guys, we are going to learn how to do reference triangles and evaluate 6 trig functions. So first let's figure out what reference angles are. So reference angles are the terminal side, remember the ending side, is always going to be the hypotenuse of the triangle. And then remember, it always has to be one of the bow ties. So bow ties is not, it's not a mathematical term, it's just a term I came up with. We are always going to have a triangle that looks like one is going to be one of those. We'll never have a triangle that looks like this. People don't wear bow ties like that. They wear them like this, okay? So they're always going to be dropping off of the x-axis, not the y. All right, so let's go ahead and find this one. So 118, so we got to just figure out what the angle, our theta angle is going to be. We got to figure out what, I think I said 118, 218 is the question. Let's figure out what quadrant we are in. So quadrant 1, 2 goes to 180, 3 goes to 270. So it's not going to be all the way to 3 because part of, we want to only go to 218. Okay. So if we have, let's see if we can make that a little clearer for you guys. If we had 218 degrees, which is all this way, and then we went just 218, wouldn't that give us that leftover piece? So if we went 218 and then subtract that 180, that would give us just that leftover pink portion, correct? Which is 38 degrees. So this triangle's reference angle, the angle we are going to use when solving the trigonometric functions, is 318. Oh my gosh, guys, I'm so sorry. 38. 38. So when we do sine, cosine, tangent, all that good stuff, we can't do 218. That doesn't even make sense because we're using triangles and there's 180 degrees in a triangle. So 218 doesn't make sense. It needs to be something between 0 and 180. So we get 38. Okay, so sorry I keep mixing up those numbers. Love the life of a dyslexic math teacher, right? Okay, so this is a radian, obviously, because it has a pi in it. I don't think radians. Even after teaching high school math for 15 years, I still don't think in radians. I think in degrees. So for me, it's an extra step, but it's such a minimal extra step and something else I don't have to commit to memory because we know how much I don't like committing things to memory if I don't need to. So I'm going to transform this to a degree. So I'm going to go by 180 over pi. If you guys know what this is and where it is in your XY quadrant system, don't worry about transforming it to a degree. You don't have to. It's just this is how I see it better. So I'm going to do it. So I'm going to cross out my pi's, and then we're going to get 5 times 180. That's 900. And then 6 times nothing is 6. And we're going to reduce that, which is 150 degrees. Okay, so now let's go ahead and figure out where that guy is. So 150, past 1, it's got to be in 2 because 2 goes to 180, right? So it's going to be here. This is 150 degrees. So this guy is 30 degrees. Okay, and then that's it. That's all we need to do, find the reference angle. So we're going to go 30 degrees. It gave it to us in terms of a pi, so we need to transform it back. We need to put it back into a radians. So we're going to go 360 times, this time we're going to go pi over 180. 30 times pi over 180. Zeros cancel. 3 goes into 18 6 times, so pi over 6. Okay, so that's just how we find the reference triangles. We're going to need that for the next step, the big step of this video, which is right here. Okay, so let's find all values of the trigonometric function. So for 210 degrees. So all values of the trig functions, that's sine, that's cosine, that's tangent, that's cosecant, that's secant, that's cotangent. Okay, we got to find all 6 of those. Okay. So first we need to find our triangle. Let's figure out, just like we did on the last couple examples, where is this going to be? It's going to be in quadrant 3. Because quadrant 2 ends at 180, and 210 is definitely bigger than that. So this thing goes all the way to 210. So if we go to 180, how much more do we have to go to get to the terminal side? 30. So we got 30 degrees there, okay? And then it says, label the sides appropriate using reference triangles. Don't forget your plus or minuses. So for a 30-degree triangle, opposite is side 1. Hypotenuse is always 2. And then this is a 1, 2, 3 triangle, so radical 3. Positive and negatives. Think about this being just an XY grid, right? If this was a point down here in the XY grid, it would be negative x, so negative root 3. It would also be negative 1, so negative 1 for that value. Our hypotenuse will never, ever, ever, ever be negative. Think about Pythagorean theorem. If we were to figure out, let's say we didn't know what that hypotenuse was, what would we do? We would do negative 1 squared. Well, negative times a negative is a positive. And then negative root 3 squared, negative times negative is a positive. Positive plus positive is a positive. So we will never get a negative value for this guy. Okay? All right. Then let's label it AH and O. So this is the theta that I'm working at. You will always work with theta here. So this is like the center of your bow tie. That's a little knot as a theta. This is your adjacent. This is your opposite. This is always your hypotenuse. Okay, so then let's go ahead and figure this out. So remember, SOHCAHTOA, or some old hippie caught another hippie tripping on asphalt. Okay, so we're going to go sine of 210 degrees equals OH, negative 1/2. Okay, then we're going to do the opposite of that one. I'm just going to do it all at one time. So then this one is going to be the cosecant of 210. We reciprocate negative 1/2. We get negative 2. All right, let's do... Okay, so now we're going to do cos of 210 degrees. Cosine is AH, so we're going to get negative square root of 3 over hypotenuse. However, when you go to reciprocate this guy, let's look at this up here. So we got negative root 3 over 2. If I reciprocate that, I'm going to get negative 2 over square roots of 3, right? Negative doesn't matter. Top, bottom doesn't matter. I can't have a radical on the bottom. So it will say, like in the directions, rationalize when possible. So you'd have to multiply by root 3 over root 3 to get rid of the square root in the bottom. So we would get negative 2 square roots of 3. Root 3 times root 3 is root 9, which really is, simplifies down to be 3. So the secant is that whole thing, negative 2 root 3 over 3. Okay, last one. Let's do some dark pink. That tangent. So now we got tangent of 210 degrees. Tangent is uh-oh. There we go again with a radical in the denominator. So let's look at that. So we get negative 1 over negative root 3. Negative over negative cancels out. So we're left with positive 1 over root 3. Can't have a square root in the denominator. So we're going to get square root of 3, or 1 times root 3. Root 3 times root 3 is 9, which square root of 9 is 3. So we're really going to get the positive root 3 over 3. And then we're going to go cotangent of 210. Now, I could reciprocate this, and then I will get a radical in the denominator again. But if I go back to my original fraction for tangent and reciprocate 1 over root 3, what's the reciprocal of that? Just root 3 over 1. So then we can just say root 3 over here, okay? So sometimes it's always handy. If you get something that you have to rationalize as the first step, keep it handy, keep it in mind, because if you just reciprocate that, you don't have to rationalize by multiplying top and bottom by root 3 over root 3. All right, so all 6 of those values are your answers for that guy.